Okay, let's do some review problems before we get into the new topic, or the topic. Or, well, it's not really a topic, it's kind of just a review assignment. So you have the square root of 96. So 96 is an irrational square root. So we simplify it by putting the division sign and see what we can divide 96 by. So 96 divided by 81 is a decimal. 96 divided by 64 is a decimal. 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 25 is a decimal. And 16 works. So I rewrite that as the square root of 16 times the square root of 6. The square root of 16 is 4. Okay, so the answer to this problem is 4 times the square root of 6. Okay, now we have the square root of 64, x to the 4th, y to the 3rd. So it's one radical, but then we have a multiplication with 3 factors. So in multiplication, we can split that radical up so it covers one of the 3 factors at a time. Okay, now the square root of 64 is not irrational. It equals 8. Okay, so that's going to go outside the radical. Okay, and then x to the 4th, that's x times x times x times x. So remember, we want to manipulate the square root so that it covers only 2 of them at a time. We're just breaking that square root down further. Because x times x is x to the 2nd. So the square root and the 2nd power cancel, giving me a full factor of x. And the same thing here. So that's 2 full factors of x, x to the 2nd. There's no square root, so that's going to go out. Okay. So far in the square root, we're going to have an 8 out and an x second out. I don't have anything inside at this moment. And y to the 3rd, that's y times y times y, so it would be right there. So it would be y to the 2nd, the square root and the 2nd cancel, giving me y. Now this y still has a square root, but it doesn't cancel. So this equals 1 full factor of y and then a square root of y. So I'm going to have a y out and a y in. Okay, now multiplication of 2 separate square roots. We think of this in 3 steps. Step number 1, we multiply the outside coefficients, if there are any. Outside coefficients, coefficients. And at the same time, we multiply the square roots together. Well, there are no outside coefficients, so we multiply our square root. So we take the square root of 75xy times the square root of 2x to the 3rd. So 75 times 2 is 150. Then x times x to the 3rd gives me x to the 4th. And then we just have this y here, because this square root doesn't have a y, that one does. Now, we simplify our new square root. Okay, so again, we have 3 factors in our new square root. Okay, so we take the square root of 150, the square root of x to the 4th, and the square root of y. Okay, there is a 3rd step which we'll discuss after we get these simplified. So 150 is not a perfect square, so that would be irrational. So we start dividing by 144, so IRR divided by 144 doesn't work, 121 doesn't work, 100 doesn't work, 81 doesn't work, 64 doesn't work, 49 doesn't work, 36 does not work, 25 does work, so we rewrite that as the square root of 25 times the square root of 6, with of course the square root of 25 turning into 5. Okay, So our new square root's going to have a 5 out and a 6 in, but then there's the matter of the variables. So x to the fourth, x times x times x times x. Now break that square root further so it covers 2 of them at a time. Okay. So x times x is x to the second, and the square root and the second cancel, giving me a full x factor. Then x second, square root cancel, give me x. So there's 2 full x factors. X second, there's no square root because there's both the square roots were canceled. And this goes out. Okay. Okay, then the square root of y. Well, y has no power. Okay, so this is already simplified, equal to the square root of y. So that y is going to be inside of our square root. And then the third step, if it's possible, is to simplify the outsides. Outside. But I don't believe that's possible because 5 times x to the second, we don't know what x's value is, so really this can't be simplified. Okay, now adding the square roots. So we have coefficient 2 times the square root of 7 plus coefficient 3 times the square root of 63. Now we have an addition. So with addition, it's not even close to being the same process as multiplication. You have to get like terms, meaning the 2's multiplied by the square root of 7, the 3's multiplied by the square root of 63, so those are obviously not like terms. They cannot be added because they're not multiplied by the same thing. So we're going to make a table. That'd be the first step. So 2 times the square root of 7, and then 3 times the square root of 63. So I drop the 2, and I discuss simplifying the square root of 7. So 7 is not a perfect square, it's irrational. So we put the division sign in. And then 7 divided by 4 is a decimal, so that would just take me to 1. Now we never really divide the square root by 1 because it just ends up 7. So this is already in simplest form. 2 times the square root of 7. Okay, 3 times the square root of 63, so drop your 3. The square root of 63 is irrational. So hopefully that will divide by one of these perfect squares. 49. It's not divisible by 49. It's not divisible by 36. By 25. Nope. By 16. Nope. It's divisible by 9 though, so we rewrite that into the square root of 9 times the square root of 7. And the square root of 9 turns into 3. So instead of 3 times the square root of 63, it's 3 times 3, square root of 7, and then 3 times 3 is 9. So 9 times the square root of 7. So now these are like terms. We put the square root of 7 down, and then 2 plus 9 is 11. Okay. Okay, now we're going to discuss what we learned in the last lesson. We have the square root of 5 times 4 minus, make it plus negative 1 times. So you have a plus in parentheses, but they're not like terms. The 4 and the negative 1, the negative 1's multiplied by the square root of 20, but the 4 is not. So we need to distribute. Now, before I do that, you want to definitely make sure you have a 1 coefficient there, because then when you distribute, it should be with the coefficients 1, 4, 1, negative 1. So I have the 1, but the 1's multiplied by the square root of 5, then I'll multiply it by 4. 4 is not multiplied by a square root. And then 1 times negative 1, but 1's multiplied by the square root of 5, and the negative 1 multiplied by the square root of 20. So this is 4 times the square root of 5. Remember, you multiply the coefficients and the square roots, but there's only one square root. 1 times negative 1 is negative 1. The square root of 5 times the square root of 20 is a square root of 100. Now bring both of these here and see if they can be simplified. So I drop the 4. The square root of 5 is irrational. So I put in the division sign. It's not divisible by 4 though, so that would just leave 1. So that means it's already in simplest form. So we'll circle that. Okay, drop the -1. Square root of 100 is not even irrational. It's equal to 10. And then -1 times 10 is -10. Now, when writing this, let's find the one that doesn't have is it multiplied by a square root? That would be the -10 plus, and then we got the square root of 5 with its coefficient of 4. Okay, and you can't add these because that's multiplied by the square root of 5. That one's not. Okay, I don't care if you keep the dot there, that's fine. Okay, 4 minus the square root of 5, well, I want to make it plus negative, put the -1 in there, and then that would be a multiplication sign, then 1 minus the square root of 5. Now again, the parentheses cannot be simplified from inside because you have addition, but they're not like terms. You got one in each one multiplied by a square root of 5, and the other one's not. So, you're doing the FOIL method now, because you have 4 -1, 1 -1. So 4 times 1. Neither one of those is multiplied by a square root. 4 times -1 times the square root of 5. -1, 1. Now the -1's multiplied by the square root of 5, and then the 1. And then -1 to -1. So -1's multiplied by the square root of 5, and so is the second -1. So this is 4, -4 times the square root of 5, -1 times the square root of 5, and then +1 times the square root of 25. Now write those over, see if they can be simplified. -4 times the square root of 5, -1 times the square root of 5, and then 1 times the square root of 25. Okay, well this is already simplified. Square root of 5 is irrational, but the only thing it's going to divide by is 1. So that's going to, we don't want to really, it's kind of a waste of time dividing it by 1, so circle it, and that'll be circled. 1 times, now the square root of 25 is equal to 5. It's not even irrational, so 1 times 5 is 5. Now we have 4 products. 2 of them are not multiplied by square roots, so that means I add the 4 and the 5. That would be 9. Then I have the square root of 5, and I actually have 2 square roots of 5, so I add the coefficients, adding them. Okay, -4 plus -1 is -5. Okay, next one, 8 times the square root of 7 plus 2, and then times 5 times the square root of 7 plus -3 times. Okay, so that's another FOIL, just like this one was. So we take 8 to 5, but it's 8 times the square root of 7 times 5 times its square root of 7. Then 8 to the -3, so 8 with its square root of 7 times -3. Then 2 times 5 times its square root of 7, and then 2 times its -3. So 8 times 7 is 40, and then the square root of 7 times the square root of 7 is the square root of 49. 8 times -3 is -24 times the square root of 7. 2 times 5 is 10 times the square root of 7. And 2 times -3 is -6. So we have 40 times the square root of 49. -24 times the square root of 7. 10 times the square root of 7, then the -6. So the square root of 49 is equal to 7. It's not irrational, so it's 40 times 7, and that's going to be 280. Okay? I could circle that. The square root of 7 is irrational, so divide, but the only thing it really 7's divisible by, the only perfect square it's divisible by is 1. So that means I'll just keep it, and the same thing with this one. And then the -6 is already in simplest form. So we would add these two, the 280 plus the -6. You add those two because neither is multiplied by a square root. That's 274. Then both of these have the same square root. So I put the square root of 7, and then negative 20 plus 10 is negative 14. Okay. Now, you can go back and work on the assignment if you want. I'm going to go over another round of examples. So the square root of 192, it's not on there, that's irrational. So divide. So 192 divided by 169, nope. Divide by 144, nope. 121, nope. 100, nope. 81, nope. 64 is 3. So I rewrite that as the square root of 64 times the square root of 3, with the square root of 64 becoming 8. So it's 8 times the square root of 3. Okay, a radical, but you have 3 factors, including 2 unknown variables. So you got the square root of 18, and the square root of x fourth, and the square root of y to the fifth. So 18 is irrational. It's not a perfect square, so you put the division in. So 18 divided by 16, nope. Divided by 9, yes. So the square root of 9 times the square root of 2, and the square root of 9 is 3. So 3 times the square root of 2. So the 3 goes out, the 2 goes in. Now what about the variables? So x times x times x times x. Remember, break it up so it covers 2 of these at a time. So that's x second, which will give me a full x factor. Give me a full x. So that's 2 full factors of x, and they both go out. So x second goes out. Y to the fifth, that's 5 factors of y. 1, 2, and then that one's a remainder. Okay? So y second, full factor of y second, full factor of y, and that y stays in the square root. So you have y second, square root of y. So y second's out, and the y is in. Okay, the square root of 27 times x to the fifth times the square root of 48 times x. So multiplication is the 3 steps. Okay, now I'm not going to write what they all are on this one. So again, you make one square root. There's no coefficients outside to multiply. So 27 times 48 is 1,296. Then x fifth times x is x to the sixth. Now you simplify your new square root just like you did up here. It's the exact same thing that you're doing up here. So the square root of 1,296 and the square root of x to the sixth. Okay, is this a perfect? Now, I don't know if it's a perfect square until I actually square root it. Ah, it actually is. Okay, so it's not irrational. I square rooted on a calculator and got a whole number. So I just put cross it out, or equal 36, and that goes out. Okay, so my new square root, 36, goes out. So x to the 6, x times x times x times x times x times x. So 2 at a time. So x second, that cancels, giving me x second, x second, x. So that's 3 full factors of x with no x remaining in the square root, so that also goes out. Okay. Now you're like, well, what do I put in the square root? Well, now you don't have a square root. If you can't put anything in it, it shouldn't be there. And then the outside is just 36, x to the third. Okay, now 3 times the square root of 12 plus 6 times the square root of 3, that's an addition sign. So we have to get like terms, which we don't have because the 3 is multiplied by the square root of 12, the 6 is multiplied by the square root of 3. So we make this table and attempt to get like terms. 3 times the square root of 12, 6 times the square root of 3. So 12 is not a perfect square, that's irrational. So you drop your 3. Okay. So is 12 divisible by 9? No, but it is divisible by 4. And the result is 3. So I rewrite that into the square root of 4 times the square root of 3. The square root of 4 is equal to 2. So now it's 2 times the square root of 3. Instead of 3 times the square root of 12, it's now 3 times 2 times the square root of 3. So this is 6 times the square root of 3. 3 times 2. You want to multiply those. So 6 times the square root of 3. This changes into this. Those are equivalent expressions. This one's the simplest one. Alright, 6 times the square root of 3. Now the square root of 3 is irrational, but it's divisible by only the 1. So we're just going to keep it. So 6 times the square root of 3. Now we have like terms because they're both multiplied by the square root of 3. So I put square root of 3 down, and then 6 plus 6 is 12. Okay, now we have the distribution problems. Got the square root of 5 times 7 minus, which would be plus negative with a 1 coefficient, plus negative 1 times the square root of 5. Okay, so we can't add those, so we need to distribute because the 7 and the negative 1 aren't like terms. That's multiplied by the square root of 5, and the 7 is not multiplied by anything. Okay, so 1 there. So I distribute 1 to 7, 1 to negative 1. Now, 1 times 7, but we got to take the 1 times the square root of 5 times 7. And then 1 times the square root of 5 times negative 1 times the square root of 5. So 1 times 7 is 7 times the square root of 5. 1 times negative 1 is negative 1 times the square root now of 25 because you multiply the square roots. Now take those products over here and see if you can make any like terms out of this. Okay, 7 square root of 5 is irrational. And when I divide, I drop the 7. But the only thing 5 is divisible by is 1, because it does not, so that takes you to 1. 5 divided by 1 is 5, so there's no point in doing that. So that will stay square root of 5. Now the square root of 25 is not an irrational square root. That's equal to 5. Okay, so negative 1 times 5, which is negative 5. Now, these are still not like terms, but they're at least simplified. So you put your whole number first, and then your 7, that's multiplied by the square root of 5. Again, they're not like terms, because that's multiplied by a square root of 5, and that's not multiplied by anything. Okay, 4 minus the square root of 2 plus negative 1 times the square root of 2, and then times 5 plus the square root of 2. So again, no like terms. So you need to multiply, but now it's a FOIL because you have 4 products to find. 4 to 5, 4 to 1. So 4 to 5, neither 4 nor 5 is multiplied by a square root. 4 to 1, well, 4 is not multiplied by a square root, but the 1 is. So when we write the 1 down, we got to put the times square root of 2 with it. Then negative 1 times 5, negative 1 times 1, 1, 1. So negative 1 is multiplied by the square root of 2 from here, and then the 5 is not multiplied by anything. So negative 1 times the square root of 2 times 1 times the square root of 2. You're multiplying, you're just repeating the same 2 factors down here that you have here. So 4 times 5 is 20, 4 times 1 is 4 with the square root of 2 times the square root of 2. Negative 1 times the 5 is negative 5 times the square root of 2. And then negative 1 times 1 is going to be negative 1 times the square root of 4. So we are multiplying. We want to multiply the coefficients and the square root separately. So now you break these down if you can. You simplify them. 4 times the square root of 2, negative 5 times the square root of 2, negative 1 times the square root of 4. Okay, that's in simplest form. 2 is an irrational square root. It's not a perfect square. But the only thing 2 is going to divide by is 1, so both of these are the same. Okay, now the square root of 4 is not irrational. It's equal to 2. So we have negative 1 times 2, and that's negative 2. Now, out of these 4 products, we got some things we can combine. I mean, the 20 and the negative 2, since neither one of those is multiplied by anything, we add those. So 20 plus negative 2 is 18. And then I have these two square roots, and they're both identical. They're both square root 2. So I can add the 4 and the negative 5 because they're both multiplied by the square root of 2, and that would make negative 1. A textbook would write that as 18 minus the square root of 2. They don't put 1s in the answer. Okay, then 8 times the square root of 3 plus 5 times 4 times the square root of 3 minus 6 plus negative. So you got 8 and 5, not like terms, because that's multiplied by the square root of 3. That one's not, and the same thing here. So that's another FOIL. So 8 to 4, 8 to negative 6, but the 8 is multiplied by the square root of 3. And we're going to multiply by 4 times the square root of 3, and then times negative 6. So done with that, and then the 5 is repeated. Now 5 isn't multiplied by a square root. And when I multiply it, the 4 is I got to include the 4, the square root of 3 with the 4, and then the negative 6 is just isn't multiplied by a square root. So 8 times 4 is 32, and then the square root of 3 times the square root of 3 is the square root of 9. I know they're the same, but you don't keep it the same when you're multiplying. You keep it the same if you're adding, but we're multiplying. 8 times negative 6 is negative 48, and then times the square root of 3. 5 times 4 is 20, times the square root of 3. 5 times negative 6 is negative 30. So we bring these four products over here. 32 times the square root of 9, negative 48 times the square root of 3, 20 times the square root of 3, and then negative 30. Okay, so the square root of 9 turns into 3. So it's 32 times 3. That's going to be 96. There's your simplifying. Square root of 3 is irrational, but it's only really divisible by 1, so both of these are already simplified. And this here has no square root to simplify. So 96 and negative 30, neither one of those ended up with multiplied by any square roots, so we add those. 96 plus negative 30 is 66. And then we have a square root of 3 and another square root of 3. So that means the negative 48 and the 20 can be added because they're multiplied by the exact same thing, and that would end up being negative 28.